Okay, we are nearing the home stretch. We just have 3 chapters left that we are covering, including this one. So chapter 20 is on dehydration and concentration. We are going to focus on the dehydration part of this chapter. So hold on, let me fix something. Okay, so since we're talking dehydration, we need to make sure that we understand why we would want to remove water. And so the key thing is, as we pretty much have hit on several times this year, is that microbes cannot grow without water and without a certain level of water also. And so the water activity in a food, the water that is available for microbes to use, controls how perishable, how long a food will last, how easily it goes bad. So there are 3 categories of food that are preserved by water activity manipulation in some way. Uh, and these are dehydrated, which is going to be our main focus for this chapter, concentrated, which we'll just touch on just a little bit, but all of the methods of concentration you aren't going to need to know. And then intermediate moisture, which we'll also just briefly touch on at the end. So what is dehydration? We are actually physically lowering the water content and preserving the food with that. It is the oldest method of food preservation. Dehydration has been around for centuries to preserve food. And its advantages are that it obviously protects food from spoilage. You remove the water, microbes can't have access to the water, and so they don't grow. It also removes weight, so it's easier to ship products, easier to carry products if you're going hiking or camping or on some other kind of trip. They take up less space. You remove the water and items shrink down. Removing weight and space, these 2 things in particular are key for uh, helping making it easier to ship and distribute foods, and as well as the advantages for consumers, having things that are lighter and don't take up as much space, like for snacking. And that brings up convenience, right? We don't have to refrigerate foods and we can have them in a package. Uh, then that is very convenient for us. In addition, there's other foods that we dehydrate that we can do what's called reconstitution, which is adding that water back and returning it to its prior state. So examples of that, foods that are convenient and then can be reconstituted would be dehydrated potatoes. If you have dehydrated milk, soup mixes, raisins would also be a convenience food, right? We don't usually rehydrate those. Instant coffee would be another one that it's a coffee, has been dehydrated, add water, and it is rehydrated and reconstituted, and then you drink it. So we're going to skip the section that is right before this one. And so that's about water activity. We're going to skip that and focus on the factors that affect the quality of dried foods. And so what we have to understand about dehydration, the dehydration process, is that heat is transferred into food and that causes the water to be released. And so these 2 things are happening at the same time. And the heat causing water to come out is good, but we also know that heat can damage foods in multiple ways. And so we have to make sure that we balance the speed at which we are dehydrating the food. The higher the heat, the faster that speed is going to be, versus the damage that can occur with high heat. So factors to consider in this there are 4 of them, are surface area, airflow, temperature and case hardening, and oxidation. And we're going to go through each of these 4 in the next slides. So let's talk about surface area. The higher the surface area to volume ratio, so the more surface area per amount of volume that you have, the faster the dehydration is going to be. There's more area for water to escape from. And so, and in addition to that, the faster the heat can reach the center, the faster that water will be released as well. And so because of that combination, you want to cut food into thin, small pieces. There's more surface area per volume, so there's more place for that water to escape. And if it's thin also, that heat is going to reach the center much faster and be able to result in that water being released from the center more quickly. In addition to making sure your pieces are thin and small, you also want to make sure that they're uniform, that they're the same size and thickness. If the pieces are not uniform, then the larger pieces may be under dehydrated and more prone to spoilage or, God forbid, pathogens. Or if you have pieces that are smaller than the average piece, those pieces might be over dehydrated and perhaps damaged by the heat and poor quality because of that. If your food is too thick, what can happen is the outside may be over dried and damaged because that outside is still going to be getting that constant heat, and the inside may not be dried enough, and so you can get bacteria or mold growth. And what will happen after the dehydration process has stopped is that moisture will eventually migrate to the outside. It will kind of equilibrate so that the moisture is pretty consistent throughout the product. And so while the outside was over dried to start with, that moisture will migrate back to the not back to, but from the interior to the exterior. And that's how you would get the mold growth on the exterior of the product, is because not all the moisture was removed and it migrated from the interior to the exterior, and then mold can grow. The second factor that can affect the quality of dried foods is airflow. So how much that air is moving in your dehydration process. And so right here, these are 3 different methods of dehydration going from home all the way to industrial. Okay, so this is a home dehydrator, and the way this one works is that there's a blower that is blowing warm air up through these trays that are vented, and eventually the warm air escapes out the top. And so you have constant air blowing, let me turn my pointer on, constant air blowing up from the bottom and through all the trays. This one right here is a commercial dehydrator that is on a smaller scale, and it has a fan, I think in the back, and then an exit exhaust point somewhere in here. But it just like this one, except bigger. It's got to be blowing air. You've got to have airflow. And this one is an industrial dehydrator. So you could see these big fans here. They're going to be blowing all the way through this whole unit, and like within here you have trays of the food that is being dehydrated. So airflow helps move that moisture away as it's released from the food. The moisture goes to the surface, the air that is flowing by picks it up and moves it away, and that allows more moisture to come to the surface, and that cycle continues. And so the better your airflow, the more rapid, even drying that you'll have. And the third factor that affects the quality of dried foods is the temperature, and it's kind of a combination thing, balancing the temperature and case hardening. And so what is case hardening, right? Well, let's talk about temperature first. So the higher your heat, the faster water is released and the faster dehydration you get, right? Pretty simple. But there is a little wrench that can get thrown in certain foods. Some foods are prone to what's called case hardening. And so what happens with these foods is that there is dissolved sugars or salts that are part of the food, right? They're just in solution in the food. And so here's this food, and here's the solid particles in the food. Okay, that's what these irregular shapes are. And the moisture is going through just small areas where it can escape. Okay, between these solid particles. And what happens with case hardening is the moisture is connected to sugars and salts, but the sugars and salts aren't going to come out of it all the way like the water. And so what happens is they get to about this point, and then the water finally gets completely released from the sugars and salt, and that sugar and salt is still there. Okay, and that builds up until finally you have this dam of sugars and salts that is blocking the moisture from being released at the surface. And so that is case hardening. The sugars and salts have kind of blocked the porous surface of the food so that moisture cannot escape as easily anymore. And so dried fruits and beef jerky are particularly prone to this. Beef jerky you add salt to, and that's part of that. And so the key thing then for managing this is that you just have to find the ideal temperature to dry your food quickly without causing that case hardening. The faster you're drying that surface, the more likely you are to have that occur. And so what is bad about case hardening too is that you get more damage on the case or on the exterior, and it's called case hardening because it's like it makes the outside like a leather suitcase, right? Like it makes it hard, enclosed hard thing. And so the other thing to keep in mind is that heat plus moisture that is still on the surface being evaporated. Think about when you sweat, that causes evaporative cooling, and that actually helps limit the damage that is occurring on the surface. Okay, so as long as you can keep moisture flowing, you're preventing the surface from getting too hot and having damage to the food. But if you don't have that moisture on the surface, because you have case hardened that surface, you're going to have overheating that occurs on the surface, and therefore damage that will occur. So in addition to being mindful of case hardening, this is also applicable to non-case hardened foods, is don't dehydrate more time than necessary. Because once you don't have any more moisture coming to the surface, you're going to switch from dehydration to damaging the food. And so having the heat on after the food is fully dehydrated will have the same negative result as case hardening can have on the surface, causing damage from the heat. Okay, and then the fourth factor that affects the quality of dried foods is oxidation. And this one should be pretty familiar because we've already talked a little bit about this exact thing before when we've talked about fruits and phenolase or polyphenol oxidase and additives. So what happens when you are drying fruits is that polyphenol oxidase, fruits or vegetables, polyphenol oxidase activity will increase with drying because you are damaging those cells, and it's going to release that polyphenol oxidase that is stored in them, and they're going to be exposed to oxygen, and you get lovely browning like this picture on the right. And so there are two potential pre-treatment methods to stop enzyme activity, broad classifications, and these are heating or adding chemicals. And so we know that when we pasteurize food, we also stop enzyme activity, right? We've talked about that before recently. So we can pasteurize with the, so pasteurization is one heat treatment that we can use to stop enzyme activity. We've also talked about blanching before, being used to stop enzyme activity, and you can do that either with boiling water or microwaves. On an industrial scale, they're more likely to use microwaves than we do at home, because it's going to be an industrial microwave with usually like there's a belt of food that's going along the industrial microwave, and it's going to be more consistent than what you have at home. But fruits are not usually blanched because they are much more susceptible to flavor and texture changes with heat. Think about peaches, and peaches, you heat them, they're going to soften quite a bit and become potentially mushy if you're then trying to dehydrate them, and not firm like you would want. So fruit generally does not undergo heat treatment for controlling that enzymatic activity because it causes other detrimental effects to the fruits. And so instead, with fruits, you often use chemical methods. And these methods are related because they both have sulfur in them, but one of them is sodium bisulfite. And so bisulfite has sulfur in that compound. And with this, the food is soaked in a solution of this for 10 to 30 minutes. And so the obvious disadvantage of this chemical method of treatment is that the drying time is going to be increased because you just soaked it in a solution of water and chemicals, and you're trying to remove all of the water from that product. And also, many consumers are sensitive to this. I wouldn't call it an allergy, but they are sensitive to it. Okay, the other method is actually using sulfur itself. And how this works is that there is a plate of sulfur that is put underneath the fruit, and then they light this sulfur on fire, and then they usually there is a video on the YouTube channel that I put up there of this process. And so they cover the, and I guess this would be like on a home scale if they're doing it, they would cover this whole thing with like a plastic tarp and have the sulfur burning in there, and it's just those fumes are reaching all of the fruit. The advantages to this method is there's no soaking, so you don't have the increased drying time that you have with sodium bisulfite, and it also inhibits insects and mold, so that can be a double or triple benefit to using this method. Disadvantages, however, is just like sodium bisulfite, some consumers are sensitive to this being in their food, and so that can cause some issues. And the other disadvantage is that it does destroy thiamine, so it reduces the nutritive value of the foods. So the advantages of chemical methods overall in general versus those heat treatment methods for controlling that enzyme activity are that heat treatments are going to destroy nutrients such as vitamin C, and so the chemical methods don't affect nutrients in the food quite as much. And additionally, we know that heat damages foods, and so these chemical methods help those foods retain their original texture and color better than heat treatment methods. Okay, so now we're going to go into dehydration methods, and most of these are all going to be pretty much food industry methods, and then we'll talk about some home dehydration methods. And so how you choose which method that you would use on a particular food is going to depend on that food type and the quality that you're desiring. Different methods end up with a different quality product. And I should add on here, it's also dependent on the cost that you're willing to pay for it. So you have a high quality product that you're desiring, you may be willing to pay a little bit more because you're going to charge more for that product. So we have 6 different types of dehydration methods. And if you understand what each of them is, it shouldn't be too hard to be able to identify them by their name. So there's tray drying, belt drying, drum drying, spray drying, vacuum drying, and freeze drying. And the nice thing about all the names is they pretty much all very much describe what the process is that is going on. So just pay attention to what the process is and understand it, and you'll have a pretty good idea of what each of these are and be able to describe it. Okay, so tray drying. This is the least costly method. It's the most simplified. It's so you load the food onto trays, and the trays are really like screens. They have holes for the moisture to flow, and it's going to take the longest of maybe there might be one more that takes a little bit longer, but it's gonna take a longer time, 10 to 20 hours. Usually because of that time, it's smaller scale operations that can't really afford a faster method, and most often it's going to be fruits and vegetables. And so this is just like that industrial scale dehydrator that I showed you before. This would be a tray drying dehydrator, or the one that I showed you before would be a tray drying dehydrator, and it's just loaded on this truck and placed in here, and then you just have fans blowing, right? So food on trays, fans are blowing, and that's all there is to it. Okay, belt drying is basically going to be the same thing, except the food is on a moving conveyor belt. Okay, and so the food is continuously being fed into this, what's called a tunnel dehydrator, but just into a dehydrator that's on moving belts. And so like this example, food is coming up here, going to be dropped onto the next level, and go this way, dropped onto the next level, here, dropped onto the next level, and come out over here, and then carried somewhere else. By the time it comes out, it is fully dehydrated. So this process has quite a wide range of time. It's 1 to 20 hours. So it can take just as long as the tray drying method, depending on how that food is loaded. If it's loaded similarly to the tray drying method, and it's just one long tunnel rather than this dropping mechanism thing that's happening here, then it might take exactly as long as the tray drying method, because the only difference is that it's continuous. But this dropping serves a function because it moves the food around and exposes different parts to the moving airflow. In addition, there could also be agitation that's going on some of these belts, and you know, kind of a tumbling action. And the more that happens, the more you're exposing different parts of the food to that airflow through the process, the faster the dehydration process is going to occur, because you'll be able to have more moisture escape. No matter whether it takes the same amount of time or shorter that versus the tray drying method, it's still going to be more efficient because it's continuous. You don't have to stop and push a loaded truck in and then pull it out when it's done. You don't have that downtime. You're just continuously adding food and receiving food on the other end that's ready to be packaged. So once it exits that dryer, the belt dryer, it is ready to be packaged. It is completely dehydrated. And I have videos, I think, of all of these methods, except maybe the tray drying method, on the YouTube channel. Okay, so drum drying. This food is poured onto heated drums. Okay, so the food is poured, and so this is a drum right here. Okay, there's a drum here. Okay, and the drum has like boiling water on the inside of it to keep it very hot. And so the heat of this drum dries the food. And then as it's rolling, there is a scraper, and you can see here, I guess the scraper's right here, and it's scraping this drum, I think. And you can see this sheet of whatever substance this is that is being drum dried and collected. And it's this sheet. And if you were to run your hand across it, it's just brittle, okay? And would crack and fall apart in your hand. So this picture looks like it's like wet coming down, but it's actually not. It's just like a very thin, dry, crackly sheet of this might be like potato starch or something like that. So this method, obviously it has to be a liquid, right? So it's going to be used for purees, for pastes, for mashes like mashed potatoes, that kind of thing. And since this drum is so hot, I mean, so hot that it in less than a minute, all the moisture is coming off of it, off the food. And it's a thin layer of food, but all the moisture is coming off this thin layer of food. It's going to work best with foods that are heat resistant, that are also brittle when dry. So like that's why potato starch is a great one for that. Okay, so the fourth method is spray drying. Should be an easy one to remember because it's exactly what it says. All right, so you also for this one have to have a liquid or a paste. It has to be liquid in substance, and very fine droplets are sprayed at the top of this heated chamber here, and like the droplets are so fine, it's called an atomizer. Now, it's not actually as small as a single atom, each droplet, but it makes the droplets extremely, extremely small, which means that they have a great amount of surface area to volume ratio. Okay. And by the time the droplets reach the bottom of this chamber, all of the moisture has left the droplet. And so this happens in seconds. Okay. And just like, I mean, you can imagine it takes literally seconds for the droplets to go from the top of this chamber to the bottom. And so the advantage of this is that the amount of actual heat exposure is quite low, right? It's seconds, right? And so even if it's very, very warm, it's just seconds that it has been exposed to that high heat. And so it's considered a very gentle dehydration method that does not damage the food that is being sprayed. So it's most commonly used for milk. So, non-fat dry milk. For eggs, making eggs into powder. So like you make eggs into a powder and then you reconstitute them, and that's like your hotel eggs if you're, on the road and you get eggs at a hotel buffet breakfast thing. Also used to make protein powders, to make flavorings, and this is also how instant coffee is made. So coffee, it goes through the atomizer, very fine droplets, and then dried coffee comes out the bottom, and that's instant coffee. Okay, vacuum drying is our fifth one. It has very high quality of it results in very high quality foods that are dehydrated, but is also very costly. And so what happens with vacuum drying is that the food is put on trays or shelves, but in a vacuum chamber. And so when you pull a vacuum, you have decreased the pressure. So the opposite of when we are using a pressure cooker, okay? We've decreased the pressure and now our boiling point is lower instead of higher, like when we have a pressure cooker, okay? And so, but with the boiling point, you're still going to get the moisture reaching the boiling point and turning to, not steam, but gaseous water. And you end up with very minimal heat damage because you don't have to heat it to as high of a temperature for the moisture to evaporate off of the food. And so great advantages to this, and you, like I said, you end up with a very high quality dehydrated food because you aren't damaging it with heat, but it does cost money, more money than other methods. And then finally, freeze drying. And so freeze drying is very similar to the vacuum drying method, except that the food is actually frozen when it's placed into this vacuum chamber. Okay, so another couple other words for freeze drying: lyophilization. Lyophilization is used quite often when you're talking about freeze drying for like pharmaceutical industry, and another word is dehydrofreezing. So you put those together: dehydrating, freezing, drying, freezing, right? So what happens here is, so you have the food frozen going in, okay, and the atmospheric pressure, they pull a vacuum and it's lowered to a point that is so low that the water sublimates out of the food, and so it goes directly from solid, because it's frozen, right, to gas, and doesn't ever go to the water, the liquid stage in between. So it goes solid, gas, and skips the liquid stage in this process. The food never thaws out. The advantages, one major advantage of freeze drying, it can work on thick as well as thin foods because pressure and our physical states, it doesn't matter whether the food is thin or thick, right? So that temperature, water is frozen, we change that pressure, and in that instant, water is now gas and escapes from the food. A negative of this method is that the spaces that were once occupied by water in that food are now open to any gas that can reach it, including oxygen, which we know is very destructive to many foods. And so this can result in reduced shelf life, actually. So like with our other dehydration methods, we have this shrinking that happens, right? And so those kind of capillaries that were the way where the water escaped from, it shrinks, and so you don't get as much oxygen exposure all throughout the food. Whereas with freeze drying, you don't have that shrinking, right? If you've seen freeze dried foods, like strawberries are probably the most common one that you've seen, and they're not shrunk; they're the size of regular strawberry slices. And so that means that oxygen can easily get in there and react. And so because of that, freeze-dried foods are often packaged in nitrogen-filled bags. Nitrogen is very inert. It doesn't naturally react, especially the way oxygen does. And so what they'll actually even do is they'll pump nitrogen into this chamber while they're depressurizing it. In order to depressurize it, they're pumping nitrogen in, and then they'll keep it in a nitrogen heavy environment and fill the bags with nitrogen so that they are limiting the exposure of oxygen to those foods. And so, as you might imagine, there is a lot more to this than any of these other methods. And so, it is by far the highest cost of the dehydration methods. I think on the last slide I said highest cost, and it really, yeah, I said costly, so highest quality and costly. But freeze drying is definitely the highest cost of the dehydration methods. Okay, so now let's switch gears to home dried foods. And so how you would dehydrate things at home. And so there are 3 methods that you could potentially use at home. One is room or sun drying. The other is oven drying. The second is oven drying. And the third would be using a dehydrator that is made for that purpose. So room drying or sun drying, this just means it's going to be the least expensive method. It just means that you have your food on a tray and it's in the sun or in a room that is dry enough that that food can lose its moisture. So it's also the most unreliable method because it's dependent on the weather. If you have a humid day, even inside your house, it's not going to be as dry as is ideal. And so it can take longer to dehydrate the foods on certain days than others. And especially in the South, or if you are, near in like a river valley or something, if it is really humid, you're never going to get some foods dry enough for this to be effective. So it works best, of course, in climates that are hot and dry. And so again, the way this works, you just have a single layer of food on a screen or tray, and it's just left in a warm, dry room or outside. Herbs are often done a little bit differently and hung on hooks to dry. If you're hanging them upside down, it kind of keeps their structure nice, and there's no reason to put them on a tray like this. The second method for home drying foods is oven drying. And so you're going to put the food on stainless steel screens. So screens that are going to have holes in it, right? So the moisture can escape in either top or bottom direction. And keep your oven at 140 to 150. So very mild temperature. You're not actually cooking anything. And leave the door propped open for that airflow, right? Most ovens don't actually have a fan, so you definitely need the door propped open for the airflow. And it's not going to be as good airflow as if you had a fan. So negatives of this method is that it certainly ties up the oven for several hours and is going to add heat to your kitchen. This is also going to be probably the more expensive method to use at home, equipment notwithstanding, like just the process itself. You already have an oven, so that makes it convenient. But the use of energy that is needed to do this method is going to make it the most expensive. So when you're doing it, you'll rotate your trays every hour or two, because obviously the tray that's closest to that open oven door is going to have more airflow. And so you rotate them so kind of have equal amounts of airflow between your trays. You can also use a microwave oven for some dehydration, pretty much just herbs, but check your manual on your microwave before you do that. I have destroyed a microwave once before trying to do this because I guess the microwave was not actually suitable for it. Luckily, it was just like a blown fuse and I was able to replace it and fix it. But I learned not to do that again with that microwave. And so how you would do that with herbs is you would have like 2 to 3 minute intervals of heating those herbs on high power, and eventually all the moisture will evaporate out of those herbs. Okay, the last method of home drying foods is using the handy dandy home dehydrator. So initial cost, this might be more expensive because you actually have to buy a dehydrator, but the energy use and using it and like not having your room completely heated up by an oven is going to be less than the oven method. And so the way these work, I already explained how the blower works, and then you have the trays that are perforated, that have the holes that allow the air to come up from the bottom and out the top. So you can control the temperatures with these, range from 135 to 150 degrees Fahrenheit. I should also say, like, there are some other methods now, like my air fryer has a dehydrator function, and I can change the even wider range of temperatures than this. And the nice thing about that is it has the fan also, and so I don't have to have an open oven, and I don't have to necessarily have one of these either, although I do. So that is that. So that's the end of the home dried food section, and now I'm going to have you skip the maintaining quality in home dried foods and the rehydration sections of the book. Okay. So concentration, we're going to cover it just a little bit. So concentration is removing just a portion of the water from a food product. So unlike dehydration, we're not trying to remove almost all of the water. Even with dehydration, there's probably still going to be a little bit left. But with concentration, it's still going to be wet. Okay. And so what concentrates are foods that are a product of concentration, right? And so they are reduced in volume by having part of the water removed. And so these are all examples of concentrates, and you'd notice that all of them are still liquid, okay? Or wet. But a good portion of the water has been removed. So the good thing, an advantage of concentration is that most of these foods are very easily reconstituted before serving because you've kept that moisture in there, you've caused less damage to the foods, and damage prevents good reconstitution. Okay. And so, and then also some concentrates are used in that concentrated form. Okay. So foods that we would reconstitute would be like our pineapple juice frozen concentrate that we used this week in lab, or orange juice. And you're just the instructions say add 3 cans of cold water along with the frozen concentrate and mix and serve, right? Cream of mushroom soup, instructions call for you to add a certain amount of water to the soup to make the soup. You don't actually eat the soup like this out of the can. But foods that are used in the concentrated form would be, for example, maple syrup. When maple syrup, that sap is extracted from the maple tree, it is very liquid. And they basically boil quite a bit of that liquid off to create maple syrup. And then condensed milk, right? Now you aren't usually like drinking condensed milk because it's very, very sweet and ugh, but it is added to recipes in this form, right? You don't water it, you don't add water to reconstitute it before you do it. Okay, and so now that is all we're going to cover on concentration, and you're going to skip the rest of the section on concentration, which is a few pages. And so lastly, just a little bit on intermediate moisture foods. This is our last slide. And so intermediate moisture foods are going to be foods that have moisture levels that are somewhere between dehydrated and concentrated. Okay, so it's usually about 20 to 50% moisture. They have more moisture removed than the concentrates, but are not completely dry. And so because of that, there is a little bit extra precautions that you have to take with those foods because they are not completely dehydrated, they are perishable. And so they are still susceptible potentially to yeast and molds. And so these are the things that are refrigerate after opening type products that they've had moisture removed and they're refrigerate after opening. So well, I would say not all of them. So they will all need something in addition to low moisture content to preserve the food. That might be that they have enough dissolved solutes to prevent the growth of microbes. And what I mean by that, solutes are salt, sugar, right? So like our salami and summer sausage, these have salt added that will help prevent the growth of microbes. Our jams and jellies, these have sugar added that will help prevent the growth of microbes. Or they might have preservatives that have been added to them. Or they could have low pH that is working in their favor. Some of these sausages have pH that is low enough to help them be shelf stable also. Or you might just have to require that they be refrigerated. So they are, lower moisture, and so they're going to last longer, but they still need to be refrigerated. And so it can be any one or more of these things that these foods require, but they're going to need at least one of them to prevent degradation by microbes and to have that preserving effect of the low moisture. So some food examples, honey is actually considered intermediate moisture, high sugar, and that prevents the growth of microbes. Jams and jellies, pepperoni, beef snack sticks, summer sausage. The book has beef jerky in with this one. I would not put beef jerky in with this one. Beef jerky is in the dehydrated foods section. But you notice all of these still do have some moisture to their texture when you bite into them on the meats. Dry figs and dates. I guess these have a little bit higher moisture than, say, raisins, for example. Fruit strips and fruit cake would be another example in here. So that is it for this chapter. So just ignore the sections that I told you to ignore and focus on the sections that I covered in this lecture. So everything on the exam will either be from this lecture or at worst in the sections that this lecture covered, but nothing from the sections that I didn't touch on at all in this lecture. Okay? All right, have a good week.